Welcome back, folks. In the last video, we talked about what the Arduino Nano is, all the different pins on it, the ATmega chip, which actually is going to do the processing, and how to connect it. Now, we're going to try and write our first program. And for the first program, we're going to be using a simple blink function. Now, if you look very carefully on your Arduino Nano, there is a LED labeled L under the power LED. This LED is a programmable LED. So what that means is we can actually program this LED to turn it on and off the way we would like. And that's exactly what we're going to do in the first program. In the first program, we're going to power up this Arduino Nano, and after that, we're going to try and program this onboard LED L to turn on and off once every 1 second. Okay, for this, let's move to our computer and open the Arduino IDE. Once you open the Arduino IDE, it's going to look something like this. You would have like a screen with a void setup and a void loop. Let's not get into it too much right now. First thing that I want you to do is click on File, click on Examples, and look for a basic example and click on Blink. Now this is already a pre-existing example created by the folks at Arduino. So we can open this up and the Arduino community at large. Once you open this up, you'll be able to see the entire code for the blink function of this LED. If you look over here, this section from line number 1 all the way to line number 23, all of these are actually hashed out. What that means is there is a slash before and a slash at the end. These are actually comments, and anything written between these two slashes is actually going to be not performing any function on the Arduino Nano. Let's truck pause. Okay. Anything written between these two hashes is not going to be performing any function on the Arduino Nano. These are just comments, and this is absolutely essential because this allows you to actually write down in your code itself as to what this code is going to do, how it's going to work, who are the people who modified it, when they modified it, what are all the details of this code. A good programmer always adds their comments to their code and makes it easy for a layperson to understand what they're trying to do at each and every step of the code. If you scroll down a little bit, from line number 26 all the way to line number 37, this is actually the code that's going to be used to turn the blink function on this Arduino Nano. Let's not go into it right now. First, let's have some fun. Let's actually try burn this code on the Nano and see what it does. Let's see if we can actually make this LED work with this example blink function the way it is. So I'm going to look on the top left of my screen, and there are two buttons over there. The first one is called the verify button. This button basically verifies your code, compiles it, and lets you know if everything is okay or something is wrong. So I just did the verification and it looks to be all good. The next button uploads this code onto your Arduino Nano. So let's go ahead and try to see if we can burn this code on the Arduino Nano and if it's actually going to blink. So I'm going to do that. And oops, there's a problem. There's an error. What happened? We did everything by the example, but something went wrong. Okay, let's look at this error carefully once again. What it's saying over here is that it can't really find the Arduino Nano because COM port 5 is not defined and the computer doesn't know where this Arduino Nano is connected. To be able to do that or to be able to fix this, once again, on the top left of your screen, you see something that says Arduino Nano. Let's click on that. Let's say select other specific board. Over here, I'm going to search the Nano. Oops. Click on it and click on COM3, the serial port that I've connected this Arduino Nano to the computer with. And once I'm done with that, I'm going to click on OK. So now my computer knows which exact port, USB port to be precise, is connected to the Arduino Nano. You have to define that. Once I'm done with that, I'm going to try and upload this program once again. And just in a few seconds, voila! Check it out. The LED is blinking. And it's blinking once every 1 second as we planned for. So now let's dive a little deeper into the code. So if you look at this code a little bit, there is a void setup loop. Void setup basically means that you're setting up this board to actually start receiving and giving out some signals. So what I've done over here is I've written pin mode LED built-in is equal to the output. LED built-in is this LED L. This is also the D13 pin if you want to be a little bit more technical. But we don't have to worry about that. We can just simply call this LED by saying LED built-in because there's only one built-in LED that we can actually program. So LED built-in is equal to the output. So that's exactly what I've done. I've said pin mode LED built-in is the output. So I've defined that in the void setup loop. So I've just told this system or this program that LED built-in is equal to the output. Next, I've created a void loop. A void loop basically goes again and again and again. The void setup needs to be set up only one time, but the void loop basically goes around in a loop, just like the word loop. It will keep going in a loop till you tell it to turn off. The first line of code over here says digital write LED built-in is equal to high. So that means write a high voltage or send a high voltage to LED built-in. That's the first thing that I'm asking this program to do. Next, delay for 1000 milliseconds, which is equal to 1 second. In the Arduino language, we only talk in the terms of milliseconds. So everything that we write is going to be in milliseconds. So 1000 is equal to 1 second. 2000 is equal to 2 seconds. You get the drift. So over here I've written 1000 milliseconds. So every 1000 milliseconds or 1 second, it's going to be turned on for. So the light is on at high voltage for 1 full second. Next, in the digital write LED built-in low, what that means is in this piece of code or in this line of code, I'm asking the LED built-in, which is once again this LED, to turn off by sending it a low voltage or giving it no voltage. By giving it a low voltage, I'm able to actually turn off this LED for a delay of 1000 milliseconds once again. So what I've done over here is I'm asking this LED to turn on for 1 second, and then after that I'm asking this LED to turn off for 1 full second before it goes into a loop, and hence the LED ends up blinking 1 second on, 1 second off, 1 second on, 1 second off. You get the drift. That's exactly what's in your program. And now if you understand this, you can actually have some fun. Next, I want you to mess around with this code. Try play around with the numbers. Maybe change the numbers to 10,000 and see what happens. 20,000. That's about 20,000 is equal to 20 seconds or 10 seconds. And see if you can variably change a few of these lines of code to be able to change the time interval between how long this LED stays on and turns off, to be able to get a better understanding of this code. So go ahead and do that and then come back for the next video where we'll take things to the next level.